Assalamu alaikum. I hope everybody is fit and fine. Let's see what we are going to solve in this video. We have already started unit number 1 of class 10. We have reached to exercise 1.4. Today we will solve radical equations. So let's see the definition of a radical equation. An equation involving expression under the radical sign is called radical equation. So for radical equation, radical sign must be there. So let's see how we are going to solve. This is question number 1.4, question number 1 of exercise 1.4. Let's see where we are going to place the radical sign. Here is the radical sign, right? So how we are going to solve it? In order to remove the radical sign, we have to take square on both sides. We'll write squaring both sides. By taking square on both sides, in the very first step of working, a radical sign will be removed. And on the left hand side, you see we are having a plus b whole square. So we'll open our algebraic identity, which will become a square means 2x whole square, 2ab. We'll insert the values of ab and we have b square. And on the right hand side, we'll be having 7x plus 16 because radical will be removed by the square. Now we are supposed to open up further brackets and we just have to solve the equation for the value of x. 2x whole square means 4x square. 2 times 4, 5 times 20x, and 5 square means 25. And at the same time, we'll move these terms to the left hand side. We'll have 7x and minus 16 equals 0. Now we are having 4x square as it is, plus 20 and minus 7x are same terms, like terms, so we'll solve them. We'll have plus 13x, and then plus 25 and minus 16 are constant terms. We'll add them. We'll have plus 9. We'll solve these two terms. We'll get plus 9. Now you see that we have converted radical equation to standard quadratic form. Now we'll further solve it. We're breaking down the middle term. 9 4 times is 36 and 9 plus 4 is 13 equals 0, right? So we'll take x from here, we'll take common. So we are left with 4x plus 9. And here we'll take 1 as common. So we are left with 4x plus 9. Again, the whole bracket is common in both the terms. So 4x plus 9. And from here you are left with x. And from here you are left with plus 1. So we got two factors. So we'll insert each factor equals to 0. 4x plus 9 equals 0 and x plus 1 equals 0. We are having x equal to minus 9 by 4 and x equal to minus 1. So we got two values of x. Now the most important thing in radical equations are that we are not supposed to write down the solution and solution set until unless we'll check out for the extraneous solution. Extraneous solution is going to be that solution which does not actually satisfy the given equation. So now we'll do the checking process. How you do the checking process? You will insert the given values which we have taken out in the given equation. So first let's insert the values. We are having the question as 2x plus 5 equals 7x plus 16, square root of that thing. Now let's insert the first value as x equal to minus 9 by 4. So instead of x, we'll just insert minus 9 by 4. And on the right hand too, we just insert minus 9 by 4. Now we'll solve both sides separately. We'll be having 2 will get cancelled by 4. So we'll have minus 9 by 4, minus 9 by 2 plus 5 equals minus 63 by 4 plus 16. Here we'll take the LCM. They are having two fractions. We'll make them 1. LCM is 2, so it becomes numerator will write. And on the right hand side again we'll take the LCM. LCM is 4 and 16 4 times is 64. Here we'll have 1 by 2. Here we'll have square root of 1 by 4. if we open up the square, we'll get 1 by 2. So you see, for the very first answer, x equal to minus 9 by 4, our given equation is satisfied. So x equal to minus 9 by 4 will go into the solution set. Let's do the checking for x equal to 1. We can write down the equation, or you can insert the values directly into the equation. Instead of x, you will write minus 1. So 2 minus 1 will solve both hand sides separately. We are having minus 7 plus 16. We are having 3. Here we'll have square root of 9. And you see square root of 9 is 3. So for both the values, our given equation is satisfied by both of these values. So both of the values of x will go into the solution set. So minus 9 by 4, comma minus 1 is the answer. Hope you understand the steps are working. Let's solve one more question related to the same type, that is type 1 we are doing. Let's write down question number 2. So question number 2 is x plus 3, square root of x plus 3 equals 3x minus 1. So we are actually doing type 1. Let's see what is type 1. I wrote it over here. The type 1 is this one. This one is type 1. Square root, in the general form of type 1, they have written down. In it we are having one radical sign on either side of the equation. Okay, it may be on the left, it may be on the right. So we are having one radical sign. So basic thing is that we have to remove this radical sign by taking the square root, squaring both sides. Okay, let's solve. We wrote one more further question. So we are going to solve it. So again, we are having one radical sign. So we'll write squaring both sides. So let's square both of these sides of the given equation. 3x minus 1 whole square. So in left hand side, square will get cancelled by the root or by the radical sign. And on the right hand side, this is the formula of a minus b whole square. So we are having a square minus 2ab, or even you can write it directly. So x plus 3, we are having 9x square minus 6x plus 1. So here we are having square term as positive. So we'll move all the terms from the left hand side to the right hand side, so that our square term will remain positive. We are having 9x square here minus 6x, here minus x plus 1 and minus 3. So we'll get 9x square minus 7x minus 2. Or you can even write down the equation like this: 9x square minus 7x minus 2 equals 0. So 9 2 times is 18. So let's see, can we break the middle term? Yes, we can. So here we'll have 9x and plus 2x minus 2 equals 0. So again we got 4 terms. We'll pair them up. We'll take common factor. From the first two terms we have 9x as common. We are left with x minus 1. We are having 2x common. We are left with 2x. We are left with x minus 1. Let's solve it further. For the value of x we are solving. So here x minus 1 and 9x plus 2. We got two factors. So we'll equate these two factors one by one equals to 0. So 9x plus 2 equals 0. We are having x equal to 1 and x equal to minus 2 by 9. So before writing down the answer in the solution set, the process which is required is the checking process. So now we are going to do the checking. One by one we'll insert the values of x into the given equation. So what was the given equation? Let's write it first. Square root of x plus 3 is equal to 3x minus 1. So first of all, let's insert, instead of x, let's insert 1. And now we'll solve the sides separately. We'll having 4 here. we'll having 3 minus 1 here. When we open the square root, we'll get 2. So 2 equal to 2. This means for x equal to 1, the equation is satisfied. Let's solve it for the value of x equal to minus 2 by 9. Now I'm inserting the values directly because the equation is written already there. So minus 2 by 9 plus 3 equals 3, and minus 2 by 9 minus 1. This is the equation. Now we are having, let's solve it. We'll take, as two fractions are here, so we'll make them as one fraction because we have to simplify it. So we'll get 27 here, and on the right hand side, if you see, we'll get, it will be cancelled. So we'll be having minus 2 by 3 minus 1, right? Here we'll have square root of 25 over 9, and here we have two fractions, we'll make them 1. So when we open this 25 by 9, it will become 5 by 3. And on the right hand side, when you solve it, we will get minus 5 by 3, which is not equal to each other. So our one solution will be x equal to 1, and for x equal to 2 by 9, we'll write it as an extraneous root. Let's write down the answer. So you write answer like this. That solution set will be x equals 1, and extraneous root will be, extraneous root is minus 2 by 9. So this is how you are going to solve these radical equation. Let's solve one more equation of the same type. That is going to be your question number 3. Let's solve it. Question number is 3. 4x equals square root of 13x plus 14 minus 3. So how we are going to solve it? To convert it into actual standard form of radical equation of type 1, we'll just do the minor rearrangement. We'll take this minus 3 to the other hand side of the equation. So we'll have just one radical term on the right hand side. So that if we take this square on both sides in the very first step of working, we can easily get rid of this radical sign. Now our equation in the standard radical form of type 1, so we'll just write squaring both sides. So we'll just square both sides, whole square, and having 13x plus 14 whole square. So on the left hand side, if you see, it is the first algebraic identity. You just have to open it, a square plus 2ab and plus b square. And on the right hand side, you are having square will get cancelled by the root, and you are having just the same term, 13x plus 14. Now what you'll do, just open up the squares and find out the values for x. That's 9. And we'll take also these values to the left hand side. So we'll be having 0 over here. So now we'll solve further. Become 16x squared plus 24 and 13 are same terms. So we are left with 11, and plus 9 minus 14 is our same term. So we are left with minus 5. So let's see further. Can we solve it can you break the middle term? Yes, we can. 16x squared plus 16x minus 5x and minus 5 equals 0. So 16x will be taken as common. We are left with x plus 1. Here we'll take minus 5 as common. You are left with x plus 1. Again, the whole bracket will be taken as common. So you are left with 16x minus 5 equals 0. So now we'll equate each factor to 0 one by one. We are having either x plus 1 equals 0 or 16x minus 5 equals 0. Here we are having x equals minus 1 and x equals 5 by 16. Now before writing down the answer, we just have to recheck whether our question satisfies these given answers or not. For checking, let me write down the original equation. That is 4x equals 3 square root of 3x plus 13x plus 14 minus 3. Now instead of x, we'll just write insert 1 first. So square root of 13 into 1 plus 14 minus 3. 4. So it was minus 1, sorry. We just have to insert minus 1 instead of x. So it becomes minus 4 minus 13 plus 14. You just have to solve it. Left hand side is already solved. We are just simplifying right hand side. We'll get 1. Square root of 1 is again 1. 1 minus 3. And if you see, these two terms are not equal. So we cannot write x equal to minus 1 in the solution set. So this will go into the extraneous root. Let's now solve the values for check it for x equal to 5 by 16. Let's change the color so that you can easily identify the values. So instead of 4, we'll just write 4. Instead of x, we'll write 5 by 16 equals square root of 13. Instead of x, we'll write 5 by 16 plus 14 minus 3. So let's see how we are going to solve it. Here we have 4 1 times 4, 4 4 times 16, so 5 by 4. So our left hand side is solved. Now we'll solve the right hand side. 15 3 times is 65 by 16 plus 14 over 1 we can write. And here we'll just take the LCM, which is 16, and 14 into 16 is 224. And when you add up the numerator, you'll having 289 by 16 minus 3. Let's check 5 by 4. 289, if the square root of 289 is 17, the square root of 16 will be 4. And here now again we have to simplify the right hand side. We'll have 4, we'll have 12 here, and so you see 5 by 4, and when 17 minus 12 will solve, you'll get 5 by 4. So left hand side is equals to right hand side. So you see for x equal to 16, our given equation is satisfied. So now at the end we have to write down the solution set. Let's see how we are going to write it. Solution set, and in the solution set you'll just write 5 by 16, and for the extraneous root we'll write as minus 1. This is the extraneous root. So I hope you understand the steps of working for finding out the solution of radical equation. Let's solve further one more question of the same type 1 of the radical equation. That is question number 4 of same exercise. Square root of 3x plus 100 equals, sorry, it's not equals, minus x we are having here, minus x equals to 4. Make sure while writing down the question from the question paper or from the book, just recheck it once or twice. Again, we just have to make one arrangement so that we'll just have one radical term on one side of the equation. So the square root of 3x plus 100 will have 4 plus x, or x plus 4, it is one and the same thing. So now let's say squaring both sides. When you do the squaring both sides, you just have to take the square of both sides. Square will get cancelled by the radical sign. On the left hand side you are having 3x plus 100, and on the right hand side our just square will be open. We are applying the first algebraic identity. Let's move all the terms from the left hand side to the right hand side, because here we are having x square with the positive sign. Minus 3x plus 16 minus 100. So here we'll have x square plus 5x minus 5x minus 84. Or you can write x square plus 5x minus 84 equal 0. Now we are supposed to further factorize it. So we'll break the middle term. So we'll use the two factors as 12x and minus 7x. And then we'll just take further simplification by taking the common factors. We'll having two common factors. We'll equate each common factor to 0, or x minus 7 equals 0. We are having x equal to minus 12. We are having x equal to 7. So now, before writing down the answer, we have to do the checking process. Let's do the checking process. Let me write down the equation. Original equation was square root of 3x plus 100 minus x equals 4. So first we'll insert the value as minus 12. Instead of x, we'll write minus 12 plus 100 minus, again minus 12, so it will become plus 12 equals 4. Minus 36 plus 100, when you solve it further, plus 12 equals 4. When you solve it, you'll get 64 plus 12 equals 4. When you just take the square root, becomes 8 plus 12 equals 4, and you see the two terms are not equal. So we cannot write x equal to minus 12 as solution set. Let's check it for the value of x equal to 7. So instead, so let me change the color. So 3, square root of 3, instead of, now I am inserting the values direct. Instead of x, you'll write just 7 plus 100, and instead of this minus x, you'll write just 7, and this equals 4. Let's see, our left hand side will become 21 plus 100 minus 7 equals 4. It becomes 121, then it becomes 11, and now it becomes 4 equals 4. So at the end you have to write down the solution set. See, for the value of x equal to 7, the given equation is satisfied, so the value will get into the solution set. It becomes 7, and the extraneous solution, or the extraneous root you can say, will be minus 12. Right? So this is how you are going to solve the equation, radical equations of type 1, by squaring it, so that you can remove the radical sign. At the end you have to do the checking for the values of x, and if the equation is satisfied, then you will write the solution set, or if it is not satisfied, then you just have to write down the extraneous root. Hope you understand the steps of working. If you don't, then do mention in the comment. Thank you so very much. Allah Hafiz.